Hello and welcome back. I've got a alignment signal being fed into the Kriesler 1188 now, and that alignment signal is coming from a digital sweep generator which uses a ramp signal, digitally generated ramp signal from a 4-bit counter to generate 16 discrete steps. Those steps then drive a 4046 phase lock loop oscillator, and it's centered around 455 kilohertz, so this enables a plot of the IF bandpass to be seen, and the oscillator can be stopped at each of those steps and at its frequency measured, and this gives a very accurate way of marking which frequency you're observing. So I'll turn up the volume a bit and you should be able to see the curve of the bandpass a bit more clearly. Because there are 16 steps, the actual centre point of the bandpass is not displayed, so you've got one step on either side, and you can see there's a bit of noise on the signal. That's not coming from the generator, that's actually coming from a little bit of RF left in the receiver. Anyway, I've checked the alignment of the local oscillator for at 600 kc and 1.5 megs, and it's pretty accurate, so there wasn't much worth showing there. I've also peaked up the trimmer on the aerial coil for maximum at 1500 kc, and there's not much left to do on the alignment there, so I'll just show you the effect of adjusting the IF on this bandpass characteristic, and I won't go into full explanation of how the generator works, so I'll leave that as a separate video, but it's a very interesting device. Anyway, I'll bring up the volume again, and you can see the effect. You see the response curve is getting smaller, the maximum response is actually there. So I'll change the centre frequency of the sweep generator. Which obviously needs to be built up on the circuit board, not just the breadboard. Prototype board, that is. So, that was the first IF transformer at the top. This is the second. As you can see, they're pretty close. How I'm going to get to the underside of them without getting in your way, I don't know, but I'll give it a go. That was the first IF tranny, this is the second. It's getting pretty close. Although with that last one there does seem to be a little bit of an asymmetry there. See if we can shift that a bit. Anyhow, that's largely it. I'm just sort of fine-tuning it a bit in the main. It's done. I'll switch the generator off. Actually, I can turn that down. and take the generator output off after doing something a bit with the crow there. So that's that RF I was telling you that was on the output of the receiver where the volume control is going to the crow. So if I turn the volume up again now and we go over to
Phil Johnson reports.
The 83-year-old Northcote man was on Flinders Street in Melbourne CBD last Thursday
just
week
put
when
the
a group of pedestrians
this light off.
was driven into the crowd. Police say the man
Being a
died last
fluorescent.
night at the Alfred Hospital. He's been remembered by family as a friend to all and a proud citizen of
The fluorescent light there generates enough buzz to affect the receiver a bit. But as you can see, there is a little bit of RF. It's a bit of local oscillator actually on the top of the volume control.
There's still a large number of people they're yet to contact.
Australian actor Jessica Folkholt remains in a critical condition in hospital following a fatal crash on the New South Wales south coast earlier this week.
Like that.
The 28-year-old is...
And I'll just show you putting the radio on again and getting a bit more interference. The light back on. The setup underneath the crow. As I said, lighting is a bit difficult here. So there we go. Nice listen to the radio.
A report will be prepared for the coroner following the tragic death of a toddler who was run over by his father in a driveway north of Brisbane.
Nice clear reception.
The 3-year-old boy became trapped under...
The lighting is necessary, of course, for you folks to see what's going on. I suppose that it's an incentive to get a lamp that doesn't interfere with the radio so that it can be used at the same time without causing problems. So that's the end of this series on the 1188. And I hope you've enjoyed it. It's been a repair series rather than a rebuild, and as you've seen, although it is a radiogram, it doesn't actually come out of a console at the moment, because when I got it, it is as you see it. Didn't even have the selector switch for which input you want to listen to. So, being a device which likes driving 15 ohm speakers, I've got a couple of them attached to it at the moment. But I've got another solid state receiver made by HMV, which also would like 15 ohm speakers. And of course they would like a turntable to drive them, so I'm thinking of building this one and the other one, when I get it going again, into the one console and have them so they're both selectable from valve to solid state and both running 15 ohm speakers, which is a bit rare. Now, a lot of valve things are 4 ohms, or of course modern solid state is 8 ohms. So I may do a series on that later on, if and when it happens, but I hope you've enjoyed this one, and it shows that a full restoration is not always necessary. Just fixing the faulty components will get you where you want to go. The only thing is the longevity of the repair, whereas some of those other components may go later. But just fixing the main ones which are faulty in the shorter term works okay. Anyway, all the best and bye for now.